Welcome to Global Virtual School students. This is your first year chemistry class. I'm Dr. Ijal Bano, and today we are starting a new chapter that is gases. This is chapter 4, and gas is the state of matter. Other states of matters are like liquid, solids, and plasma state. In this chapter, we will discuss majorly the gaseous state and its relevant laws, and then very just properties of the plasma state. So in this chapter, though majorly we will discuss the kinetic molecular theory of gases and the motion of particles of gas, how the gas particles move in different directions, or they have some other type of the movement. Then we will discuss the absolute temperature scale that is based on Charles law, because this is a temperature scale. We have different temperature scales like Fahrenheit, Celsius, and Kelvin scale. Then we will discuss the relationship between temperature and average kinetic energy of particles. How the average kinetic energy of the particles is related to the temperature. This is important. And we will discuss the gas pressure of the gas. What is the pressure of the gas in the light of kinetic molecular theory? Then we will discuss the effect of change of pressure on the volume of gas, that is called Boyle's law, and the effect of change of temperature on the volume of the gas, that is called the Charles law. And now what is the absolute zero? Because this is a temperature, and what is its value in Kelvin and Celsius? And then we will discuss another law for gases, that is Avogadro's law, and its significance. And then we will discuss the ideal gas equation, that is also called general gas equation or universal gas equation, or this is called equation of state for an ideal gas. And then we will drive how to drive the ideal gas equation from the laws, and what is the standard temperature and pressure, and what is the significance of this ideal gas equation, and we'll drive different units of the ideal gas constant R. And then we will discuss the derivation from ideal gas behaviors, that is why ideal gases deviate from the gas laws. And we will discuss the van der Waals equation, Dalton's law of partial pressure. This is also for gases, and its application in our daily life. And we will discuss the Graham's law of diffusion. Again, diffusion and diffusion is another property of the gas. On the base of is the law that is called Graham's law. And then we will discuss liquefaction of the gases, how gases be converted into liquid, that is by Lind's method. And then we will shortly discuss the fourth state of matter, that is called plasma. In plasma we will discuss what is plasma and its properties. So because plasma state is relevant to like gaseous state, so we are going to discuss this plasma state with these gases, but gaseous state will be discussed in detail. And in next lectures, so in next chapters we will discuss liquid state and as well as the solid states. And basically this gaseous state chapter, this is built on the base of your previous knowledge in 9th or 10th grade, that you you were familiar about some simple physical properties of gases, like about their shape or volume, either they have definite or indefinite shape or volume, what is the distance between different particles of the gases, if they are diffusion and diffusion. But now we will discuss in detail its properties on the base of kinetic molecular theory, and two laws, Boyle's law and Charles law. You have learned about it in 9th or 10th grade, but here in addition to the Boyle's law and Charles law will be discussed in detail, as well as some other laws like Avogadro's law, Graham's law, and like Dalton's law of pressure we will discuss in this chapter. And the students, what you will understand at the end of this chapter, after completing this chapter gases, what you will learn, what are the objectives to learn this chapter. So these are, after completing this chapter, you will be able to list the kinetic molecular theory, its postulates, what the kinetic molecular theory says about the gases, and then you will be able to describe the motion of the particles, according to kinetic theory, what the kinetic theory says about the motion, how these gas molecules move, what are different types of motions that a gas molecule possesses. And you will be able to state the value of standard temperature and pressure. So what is the value of standard temperature and what is the value of standard pressure, and you will be able to relate temperature to the average kinetic energy of the particle in a substance. Every substance has some type of kinetic energy, so temperature, how this temperature is related to the average kinetic energy of the particles. You will be able to use kinetic theory to explain the pressure of the gas. You will be able to define the gas pressure, and you will describe the effect of change in pressure on the volume of gas as well as effect of change in temperature on the volume of gas by two laws, that is Boyle's law and Charles' law. Then you will be able to explain the absolute zero and its importance, or you can say its significance, why we need to draw the absolute zero. You will be able to give its value in Celsius scale as well as in Kelvin scale, and you will be able to state and explain the importance of a significance of the Avogadro's law, and you will be able to derive ideal gas equation using Boyle's law, Charles' law and Avogadro's law. How the ideal gas equation is derived using three laws: Boyle's law, Charles' law and Avogadro's law. You will be able to explain the significance and different units of ideal gas constant, that is R, and you will be able to distinguish between real and ideal gas. Gases are ideal according if they obey the gas laws, but they are not ideal if they do not obey the gas laws. So non-ideal gases are also called real gases. So you will be able to distinguish between non-ideal, that is real, and ideal gases, and you will be able to explain why non-ideal gases, why real gases, they deviate from the gas laws. They do not obey the gas laws, why they do not obey the gas laws, and you will be able to define and describe the properties of plasma. And we will also discuss few, we will also be able to give its applications. And the total number of lectures, other than this introduction about the chapter 4, there will be at least 12 lectures. This chapter will be covered in 12 lectures, and in this we will provide you all the solved examples and questions. We will discuss relevant to each topic in relevant video lectures, and some of the questions will be given to you for your practice, so that you will be able to understand completely the concept of gases and its relevant laws, their applications and all the theories. Hopefully you will, after completing this chapter, you will be able to complete your objectives of the chapter 4, that is the gases.